Good morning, everyone. Welcome to Code Elixir London. I'm really excited to be here. Every time I go to a conference, I get to learn something new. I get to meet new people and I get to catch up with old friends. By speaking to others, I get to evaluate where I am with my learning and where I am on my learning curve. How about you? If I show you this learning curve, where do you think you are on it? Raise your hand if you think you're a beginner. Few, welcome. Raise your hand if you think you are in the middle. Cool. Raise your hand if you think you are an expert. Good, Martin. What if I tell you that the learning curve actually looks more like this? This is called a Dunning-Kruger effect, and it's been inspired by a crime. In 1995, MacArthur Wheeler robbed 2 banks in America in broad daylight. He was surprised later when he was arrested, as he believed that covering his face in lemon juice would make him invisible to the CCTV cameras. Inspired by not only his incompetence, but also his lack of awareness, researchers Dunning and Kruger ran a series of studies to see if lack of ability is linked to low level of self-awareness. What they found was quite interesting. The less a person knew about a subject, the more confident they were. On the other hand, the most competent seemed to underestimate their ability, and this is called as a burden of expertise. Thus, in an article, unskilled and unaware of it, the Dunning-Kruger effect was born. My name is Tetiana Dushenkivska. I work at Clever Bunny, where we provide consultancy and training. And today I would like to share with you a challenge, a story I've been recently faced with. I had to help a team of developers to navigate across the valley of despair to the slope of enlightenment. So the challenge was, I had to help a team of 5 to become confident with Elixir in 3 weeks. The team already had experience with Python and Go, and they began their journey with Elixir. The extra challenge was that they still had to deliver at work. Before accepting this, I had doubts. What if I'm not good enough? What if I wouldn't be able to understand their business needs, business requirements? What if I wouldn't be able to transfer what I know? But I knew that I'm further along on the learning curve, so I should be able to help. So, doubts aside, challenge accepted. Now, let me ask you, if you were faced with a challenge like that, how would you help a team of 5 to become confident with Elixir? This is what I did. 3 steps to achieve the goal. First, understand what gives me confidence. Second, identify team knowledge. And third, build team confidence. So let's start with what gives me confidence. A few things: confident design and confident code. What do I mean by confident design? Well, there are a few things I consider or group under this category. One of them is purity. Purity is understanding of concept of pure functions and striving to separate your pure code from impure. It's one of the first concepts you come across when you start learning functional programming. It's the one which could easily slip away when you actually start working on a real-world project. The question is, why should one care about purity? There are quite a few reasons for that. With pure functions, the dependencies are explicit. Pure functions are portable. You could easily copy function from one module to another. pure functions are testable. You could pass in an input and it could easily evaluate on an output. Given this, pure functions are memoizable because the answer of the first invocation can be remembered. So functions only need to be called once, which makes them fast. Given the same input, you always get the same output, and thus referential transparency is preserved. This makes pure functions easier to write and reason about. This contributes to a code base that is more maintainable. Also, pure functions allow writing parallel code. We can run any pure function in parallels, since it does not need access to shared memory, and it cannot have any race conditions due to some side effects. What else gives me confidence? Understanding what data types are available to me and when better to use them. Here is an example of how I choose when to use each data type. So we know that in Elixir, it's idiomatic Elixir to use parameters if you use maps to pass parameters and to use keyword list to pass options. The question is, why would you use one associative data structure over the other? Associative data structures where we associate a key to a value. So why would you use keyword list instead of a map to pass options? The answer lies in the characteristic keyword list preserve. Can you name them from the top of your head, Martin? Sorry, not to worry. I've prepared a little game of discovering those characteristics. Do you know what this would return? Anyone? Syntax error. That's because in keyword list, keys must be atoms. How about this one? Yep, 1. That's because keys, that shows us that in a keyword list, the keys are ordered. How about this one? One? It's a list with 1 and 3, which shows us that in a keyword list, you could have more than one key with the same name. And these characteristics are what prompted keyword list to be the default mechanism for passing options for functions in Elixir. And knowing those characteristics and taking advantage of them, Actor provided us with a beautiful DSL for writing database queries. A good understanding of types helps me write idiomatic and performant Elixir. Code organization is important in giving me confidence too, because well-organized code is easy to understand and maintain. I like to organize the project using umbrella applications. Why using umbrella applications? I have 4 reasons to do that. With an umbrella, the dependencies for each application are clearly defined in a mix file. Let's have a look at an example. Unfortunately, all the consultancy work I did, I had to sign the non-disclosure agreement, so I can't share with you code from those projects, but we own the Elixir flashcard project, so all the real-world examples are going to be coming from there in this presentation. So let's have a look at an example. Here we have 3 applications. Auth has sole responsibility of handling web requests. Auth's sole responsibility is to handle authentication using Guardian at the moment. To store data, you'll talk to store application, which uses Actor as a dependency. Auth doesn't know anything about Guardian, store, or Actor. And if we were to replace, let's say, Guardian in Auth application, Auth wouldn't need to know anything about it. Another reason to use umbrella applications is that they allow you to design with deletability in mind. That's an idea borrowed from Greg Young. The idea is that you can delete or replace a functionality quickly. Let's say that we want to change our auth application. So instead of using Guardian, it's going to use some custom authentication. With current design, it's really easy to do that. We'll write our auth2 up, and then once we finish with that and we don't need the old one, then we just delete it. And the good thing that auth-web or store doesn't need to know anything about that change. This is how I see it. Imagining that you need to unplug something from a system like that. Would you prefer to work with the structure on the left or the structure on the right? Another reason to go with umbrella applications is the ability to have an application per DDD context. DDD being domain-driven design. Using the same terminology in the code base as in business helps developers and business people to communicate easier. Let's have a look at an example. So here is an example of using ubiquitous language within the umbrella. In auth application, our user called user. But in the games department, they don't refer them as to users, but they are players. In a shop, it's a customer, and in editor, it's an author. But all of those applications, their schemas, they talk to the same table in a database. Last reason for using umbrella applications is not applicable to everyone, but only those who are deploying with releases. You can have lots of applications under umbrella, but only choose to deploy or include in the release the ones which you need for that server. So here is an example from our flashcard project where we have a few applications. But if we were to deploy our editor, we would include only a subset of applications. If we were to deploy a game, then it will be another subset of applications. And if it's a shop, it's again another subset of applications. And the key here is that we get to keep all these applications, the whole project in one Git repository, which for us work really well. So, clear dependencies, deletability, separation into context with ubiquitous language, and deploying with releases are the reasons why I would use the umbrella applications. However, there are times when I wouldn't use umbrella applications. For example, if the project is very simple, I find that umbrella applications may be an overkill, or if I don't know what is the right way to abstract the code into those, to break it into those applications. In this case, I would start with monolith, and then once I learned the domain, what is the right way to separate things, then I would go and refactor it. Because the last thing I would want is to end up with those circular dependencies. If you come across them, they're not really fun. As Sandy Matt said, bad abstraction is worse than no abstraction. So I like the applications within the umbrella to have a good README and clear, well-defined interface or public API. There are a few pros of using interfaces. You can define a clear public API, taking advantage of Elixir ability to add nice documentation and specification to functions. Here is an example which comes from auth module. So here with the module doc, we specify what kind of functionality is in this application. Then we list all of the publicly available functions with their documentation and specification. Here we use dev-delegate to delegate to the sub-context. Another reason of using interfaces is that they allow two teams work simultaneously on two different apps as far as they have the same clear contract and they keep that contract. Another advantage is that keeping the same contract allows you to replace the underlying implementations and be sure that things still work. However, some of you may say that organizing project in umbrella applications is useless because there is no guarantee that all the calls are going to go via that public interface. And this is a fair point, and this is fair enough. And I know that some of the teams may decide not to break it into interfaces, but for me, it's kind of, I still like doing it. So, umbrella applications with clear interface. And inside context, I strive to write as many pure functions as possible and push all of the impure stuff closer to the boundary. Another thing I strive for is create a struct as soon as the data cross the boundary and then pass that structured data around the application. That saves me from passing some invalid data down the stack and see it breaking things. Also find that validating the data when you create a struct is quite helpful, because if data is invalid, you could return the error message straight away, and then you don't need to populate your business logic with all of this formatting for error messages. And here is an example coming from shop application where we create a new order struct and then we pass it around that context. I love using structs, and I have a few good reasons to do that. Structs provide a compile time guarantee, as shown here. Do you know what this would return? Key error. And this one? Here we use inverse keys. Argument error. Also, structs provide tighter type check, as I can pattern match on the type of struct in the function head. I know that not everyone is in favor of this approach. It's just something I like doing when it fits. So here is an example of adult struct. And we create an adult where the age must be more than 18. And then if we have a drink module, and then we could pattern match on the type of struct in the function head, and if it's an adult, we allow that person to drink a beer. However, there is a danger lies in this code, in this approach, and it lies in how structs are defined. Let's have a look. Do you know what this would return if we go through the constructor function? Function close error. However, if we create struct using the curly braces, it will return as a struct, which then results in a problem where teenagers and children are drinking alcohol, which is not good. It's the same kind of problem as with interfaces. There is no way for us to enforce that you would go through that interface. You could easily bypass it. With the structs, you could also bypass going through through the constructor function. We could fix this. We could add a guard clause. And then there you go, that would work. But then we have to add the guard clauses everywhere. Well, that's the choice we have to make. We could agree with the team to go through the constructors and through the public interfaces, but again, there is no way to enforce it. And another reason to use structs is they allow to write composable and extensible pipelines. And if you look at Actor library, we get to see a lot of great examples of it. So, in summary, this is how I like to organize my project. Separate pure from impure, push impure stuff closer to the boundary, convert data to structs as early as possible, and use structs within the context. But how about processes? I like them too. I tend to settle for a simple workflow now. I would TDD my implementation, and then once that is all working, I would add state or concurrency by wrapping it into a process. And then I would make it fault-tolerant by adding a supervision tree. I'm yet to meet the project where this workflow wouldn't work, but I'm looking forward to see that if I do meet that one. By working with processes, I've learned a few things over the years. One of them is you've got to restart the gen server with a new state. Why? Well, the corrupt state is likely to be the reason why the gen server failed in the first place. So if you're gonna restart it with the corrupt state again, guess what happened? Well, it's gonna fail again. And if you exceed number of retries within the given time, then you could take the parent down and you could take the whole tree down, which is not good. Another thing I strive to do is to take the functionality out of the process, in most cases. Well, why? It makes it easier to maintain, as extracting functionality into module allows you to use an intention revealing names and ability to write documentation and specification to functions which take a state and then return a new state. And also it's easier to test, as your test now can use a ubiquitous language. Here is an example of a worker. I can't see it really well, but what's happening here? We have a handle call function which shows you the next card. In this example, the functionality is inside the process. Now, if we take the functionality out, it's a little bit easier to see what's happening and to see the life cycle of the process. So, purity, types, organization, and architecture are the things which give me confidence in my project. Writing applications on the Beam involves message passing between processes. In order to ensure applications remain decoupled, I find that event-based architecture is a good fit, not to be confused with event sourcing. What I'm talking here is event-based architecture, where you send all of the events to a central broker, and all of the listeners to that broker, all of the subscribers receive the events and process them. And this architecture called broker topology. With this architecture, you can decouple your application. So, being confident in the way you design your project is great, but it's also good to know that what you've designed is working now and it will be working tomorrow. This is what confident code is about. So here we have our beautiful project which we designed, we coded, and it's all good. How can we make sure that it all works? Well, first thing is unit tests. I would have them in place by the time I finish my implementation, because I tend to TDD my implementation. Another one is integration tests. They also make me confident that things do work. With the integration tests, you can ensure that applications work together. For example, in our project, we're making sure that auth web works with auth. And we could also mock the external dependencies for auth to make things faster using like mocks library, something like that. However, I do not recommend mocking the database. We went down that route and it was a bit painful. And this is like a foundation of protecting our code. Next up, I like the style to be consistent with the rest of the Elixir community. This is where I would use formatter. To make sure that the things are consistent within the project, I would use Credo, and test coverage to make sure that I'm not forgotten any test. And next up, I'll use the serious guys. Dialyzer would make me confident that the specs are aligned and potentially find some bug which I didn't even think possible. With the smoke tests, I would make sure that everything works through the whole stack. So this is no mocking. We go through the browser, making the request all the way down, calling all the real things and coming back. And to be super confident, I would use property test when it fits, when it makes sense. But when things go bad, what do we do then? Well, debugging and tracing to the rescue. And with all of those tools, I have my tower protecting the beautiful Elixir code. And I have a confidence that things do work. Okay, and this is what gives me confidence. After going through this journey of understanding what makes me confident, I kind of forgotten why I was doing that. And the reason was that I could actually help a team of 5 to become confident with Elixir. So let's move on to the second step of identifying team knowledge. It's hard to help someone if you don't know what they don't know. And to identify where the team is on the learning curve, I've used a few techniques. One of them is reviewing the project. By reviewing the project, I get to understand how Elixir is used, what concepts are followed, and what patterns are used. The things I looked during the review were code organization, design patterns, and consistency. What would be the things I would look for when about code organizations? Well, the things which makes me confident. Here is an example of a few things which I found. It was very important to say what team was already doing good, not just concentrate on things they could be doing better. And once I've identified what is good and could be improved, then I had to share the feedback with the team. One of the things I've picked up on is the possibility of replacing the nested cases with with. So this is how I gave feedback to the team. Okay, I'll pick up the example from the project, then I show this example to the team, then I'll suggest an improvement. So here you can see, like if you stand back and if you squint, you could see that the code is going to the right. And this is a sign that it's time to refactor. Well, then I would provide a suggestion. Here you go, this is how you could refactor. And then I leave it to the team to decide whether they want to take on board my suggestion or whether they want to leave it. By reviewing the project, I get to understand where the team is on the learning curve. Once I reviewed the project, then I used another tool from my toolbox. Flashcards. Flashcards have a question on one side and answer on the other. They are great at identifying knowledge gaps around the terminology and Elixir API, or API in general. Let's see if you have gaps in your knowledge. Do you know what this would return? Anyone? It's gonna be a tuple, 1 nil and nil. How about this one? You must have seen this one. Undefined function error. You may have confused the list.join with enum.join, which sometimes gets me. But enum.join actually is a valid function. It returns a string. By using flashcards, I get to understand where each individual is on the curve. Also, I was using pair programming with one of the developers at the time on the team. It was a remote pair programming using Zoom. That's before the vulnerabilities were there, so it was safe. We left meeting open, so anyone on the team could join and observe the session, but the agreement was that you shouldn't interrupt the flow of the pair. After pair programming for 3 hours with each developer, I get a better idea what each person's area of work and personal goals are. Also, pair programming helped me to understand how the team member is thinking about, coming up with the solution when they're coding. And after pair programming, I realized that my initial plan of what I'm going to cover in this mentoring session had to change because I realized that the fundamental concepts like purity is not well used within the project. So initially I thought this is where the team is on the learning curve, but after pair programming, it looked more like that. And after identifying team knowledge, it was a time to fill in those knowledge gaps and help the team to become confident with Elixir. How would you build team's confidence? Via mentoring. Mentoring is not teaching or lecturing. It's about helping individual to define a goal and help them come up with all the support, direction, motivation in achieving that goal. Well, I had a few techniques which I used during mentoring. The first one is flashcards, of course, but this time as a revision tool. When you look at the front side of a flashcard and think of an answer, you engage a mental faculty called active recall. Active recall has been proven to create stronger neuron connection for that memory trace. Also, they can be used with the confidence-based repetition. Here's how it goes. Do you know which company I'm working for? At the beginning, I mentioned that it's Clever Bunny. Not that it's important for you, but that's the example I'm choosing. Sorry. If you look at the curve of forgetting, you can see that the more you recall something from the memory, the better it will stay in the memory. That's why you may remember Clever Bunny. Confidence-based repetition is a technique of remembering an information by separating your practice sessions in time. Also, I've used presentations because they are great to share the knowledge with a group of people at the same time and also have something left for reference. Let me show you an example of presentations which I was giving. So, for example, there was a presentation around purity. So first, I would identify knowledge gaps with flashcards. It was important to focus only on things which team doesn't know. So what is pure functions? Then I'll give an answer. If everyone got it right, then I'll skip the explanation. However, if anyone on the team got it wrong, then I'll explain what it is. And it was very important for me to track the progress, but don't make a person intimidated about not knowing something. So rather than saying, oh, Bob got it wrong, I would say that 4 people out of 5 on the team got it wrong. And then if everyone got it right, then I'll skip all the explanations. But let's say, for this example, 4 out of 5 got it wrong. So in this case, I would move to explanation. Say, okay, so here is an example. A pure function is the function where you're given the same input, you always get the same output. Given 1, you always get 2. On the other hand, impure function is the function where you don't know what's happening. Given input 1, you could get 2, 3, or 4. And after explanation, then I would provide them with a little test to see whether they get it and they understand the purity around Elixir. So let's play the game again. Is this function pure or impure? How about this one? Yep. This one? This is impure as we're talking to the database. Well, this one. This is pure. We are not talking to the database. And after answering what, it was quite important to discuss why. Why should you care about purity? And after answering why, it was time to move to how. How would you benefit from purity in real-world project? We all know that there is no way to write a project, well, at least most projects, without having some state, talking to the database, making HTTP requests, printing to the console, reading from the console, or things like that. So the key is to make as many functions pure and then push the impure stuff to the boundary. And this can be done in 2 steps. First, identify pure and impure functions, and second, make as many functions pure by passing in the required data from impure function. And then I would pick up an example from the project and I walk through that example. Let's have a look. So here we have an example. First, we would identify what is pure, what is not. That's pure, that's impure. What do we do with impure? We take it out, push it closer to the boundary, and pass in the required data to that inc function. So if you are striving to make that inc function pure. And if we look at this now, is this pure now? No, because it still has a logger. So then you take out that logger and push it closer to the boundary, and now you make this inc function pure, and you could easily test it. And last step was in those presentations is to provide some links to some relevant reads and presentations and things around the topic. And once knowledge has been shared, we've used pair programming. Pair programming we used to solidify knowledge in practice, to identify new knowledge gaps and to become confident with implementing the theory in practice. While pair programming was very important for me to concentrate on providing a guidance, not to take over, not to tell what to do, not to lead, but provide an options to solutions and then step back and let the team decide what they want to do within the team and what's best for them. Pair programming was really good for sharing the way I think about the problem, and also I get to remember some traps or tips which I have experienced over the years. And after pair programming with each member on the team, they kind of become an expert on the topic which we were pair programming on. So then they were mentors for the rest of the team on that topic. And I, with help of flashcards, presentations, and pair programming, had a really lovely time mentoring. I found that there are a few tips for a successful mentoring. Ask questions correctly. What I would do is that I would explain something and say, okay, do you understand that? And they'll say yes, and then I'll move on. So the idea is, don't do that. Rather, first start with, what do you understand? Get the answer, and then give an explanation, so then they get to think first. Or rephrase the question. Instead of saying, did you understand? Ask, why? What did you understand? Why is this working like that? What are the benefits? So another thing is flashcards. They do work. Here is a proof. What company am I working for? I think a few more remembered probably that it's a Clever Bunny. Another thing is it was important to provide options to the problem, not to concentrate on. When you're mentoring, it was important to explain why something happened in a particular way and give all the possible options to the problem. And it was also good to concentrate on good things rather than things that they still don't know and need to learn and things like that. Because it's motivating to know that you're doing things well, or already doing things well, starting to do things well. And another thing is, it worked when we had a challenge for pair programming, be it a feature, bug fix, some design exercise, because if there was nothing to work on, it was really difficult for me to know how I can help. So during pair programming, this is what worked. And with these 3 steps, understanding what gives me confidence, 2, identify team knowledge, and 3, build team confidence, we were able to achieve the challenge and help the team to cross the valley of despair and climb the slope of enlightenment, to become confident with Elixir. And as a bonus, I get a good feedback. It's very nice. Well, today we have talked only about one curve, the big curve of becoming confident with Elixir. But if you think about it, there are many, many, many little curves, different subjects. On some of them, you may be an expert. On some of them, you may be a beginner. So today, I would like to encourage you to become a mentor on subjects which you do know well, and seek for a mentor on subjects which you don't know well. Why would you want to be a mentor? Well, It makes you feel good about sharing experience, it develops better understanding of a subject, and it develops communication and leadership skills. Why would you want to be a mentee? Well, you get to spend time more effective, as mentor could help you to design the learning process around your personal needs, and you get to progress faster. And now, time for a little interactive session. Conferences is all about meeting new people. So, we have 30 seconds. Just turn your head to a neighbor and just say hello, say what your name is, say what you're expert on. Cool. Okay, cool. Thank you. So, it looks like successful people value mentoring. And for example, Steve Jobs, he had Mike McCullough as his mentor. Well, let's help each other to be successful. And now you could carry on your conversations. Thank you very much.